Today we're going to be going over how to write and balance word equations. The first thing you need to know is the definition for skeleton equation. The definition for skeleton equation is the chemical equation that is just kind of the bare bones. So it's going to be essentially just giving you the amount of reactants and products you have, but not necessarily balanced yet. You always want to go through when you're doing these word equations to do the skeleton equation first prior to actually writing your coefficients to balance. This list right here you do need to memorize. This is the list of diatomic elements, the elements that exist in pairs. So you never find these elements uncombined in nature. So for example, if you were writing hydrogen is reacting with oxygen, you wouldn't put H plus O. It's actually going to be H2 plus O2. So if you ever find these elements in the word problem and they're listed alone, you'll need to put a 2 next to the element when you go to write the skeleton equation. Alright, so we're going to go ahead and write our first equation. And I want to do a color you guys can see. So it says iron oxide with hydrogen. So when you're seeing these words like with, or they'll say and, or they'll say combines with, you're going to be putting a plus sign. So it's going to have iron 3 oxide and it's going to combine with hydrogen to form iron and water. So the first thing you need to do is iron 3 oxide. Iron 3 oxide is a type 2 cation because we have that Roman numeral here. So they're telling you that iron in this case is a 3 plus. Oxide we know is oxygen and it's a 2 negative. This is ionic, means we need to do the charge switching. If it's ever covalent, you just write how many of each element you have with the prefixes. But because this is ionic, because it's a metal, non-metal, we need to go ahead and charge switch. So our formula will be Fe. Let me erase that so I can have room for coefficients if I need it. Alright, so I'll do it here, Fe2O3. So that's my iron oxide and it's going to react with hydrogen. Hydrogen is a diatomic, so we needed 2. The diatomics are only listed as a 2 if they're listed alone. So if you have, water, for example, and that's not a great example because water is H2O, but if you have, hydrogen combining with something else, that diatomic rule goes out the window. So it's only if they're listed alone like this one. So your iron oxide is going to react with hydrogen to form. If you ever see forms or yields, you're writing your arrow, indicating that now you're talking about the products. And it's going to form iron and water. We all know what water is. Then what we need to do is balance. So I'm just going to go through the left and right to show you which ones need to be balanced. This one's pretty easy. You can see here that your iron, there's 2 on the left. So on the right we need a 2. There's 3 oxygen on the left. So on the right we need to go ahead and also have 3 oxygen. That's going to give us 3 oxygen, but it will also give us 6 hydrogen. So on the left-hand side, we need to go and make it 6 hydrogen as well. Then you just go through and make sure it's all balanced, which it is. You can also put a 1 here, but you don't have to. This right here is our balanced chemical equation, and this is what you're going to be using for further problems as we move along. So you want to make sure you can write the skeleton equation. You want to make sure that you can balance it. And to take it a step further, you can even indicate what type of equation this is. This is a single replacement or displacement reaction. So that's you just also indicating what type of reaction it is. Okay, let's walk through this one. Now this one has been complete, but I still want to walk through it, and then we'll go through and balance it. So one thing I want to point out that's different about this one that we didn't do on the last one, this one's indicating the state of matter that each chemical is in. it'll say solid magnesium reacts with aqueous silver nitrate. Remember again that silver is one that's not going to have a Roman numeral listed, even though it's not really a type 2, but it's in the transition metal family, because silver we know is always a 1. And then your products are going to form solid silver and aqueous magnesium nitrate. So you do need to know all of the symbols, which we discussed already, for the states of matter. So of course S is for solid, L is for liquid, G is for gas, and aqueous is AQ. If the word problem lists the state of matter, you need to write the state of matter, and you would be writing it in parentheses in the lower right hand corner. So solid magnesium, that's listed first here, is going to react with aqueous silver nitrate. How did we get AgNO3? Ag has a 1 plus because we know that silver is a 1 plus. Nitrate, it's one of your polyatomics that you need to know, is NO3 negative 1. The 1's cancel and we're left with AgNO3. We know that magnesium is a solid, that's why the S is listed, and silver nitrate is aqueous, so we put the AQ. It's going to react to form solid silver and magnesium nitrate. To determine magnesium nitrate, you can see the work shown here. So you'll see that magnesium is a 2 plus, and that's based on its family charge. Nitrate again is NO3 negative 1. You do need to switch this one because there's a 2 and a 1. When you go to switch, you want to make sure that your nitrate's in parentheses because you don't want 32 oxygen. You want 2 nitrates. Also, nitrate was aqueous, so that's why we listed the AQ. Now this is the skeleton equation, but we don't have the coefficients written in yet, so we need to go through and balance. Okay, on the left we have 1 magnesium, and on the right we have 1 magnesium. On the left we have 1 silver, and on the right we have 1 silver. And on the left we have 1 nitrate, and on the right we have 2 nitrate. You are allowed to group the polyatomics together again. I went over this before when we went over balancing, but as a reminder, you are able to group them together as long as the polyatomic is the exact same on the left and right. So do you see how NO3 is the same on the left and on the right? It doesn't break apart or change. So I'm actually able to group this in my chart if I was using a chart to balance. So I have 1 NO3 on the left, I have 2 on the right, so I need to go ahead and put a 2 here, indicating I have 2 NO3s. That also changes my silver to 2 on the left, so now I need to go on the right and put a 2. You can put 1s here indicating that that's the coefficient, or you can just leave it blank. That is your balanced chemical equation. That's what we're going to be looking for because we need these coefficients in a lot of the problems that we're going to be completing in the future. The other thing, again, you can indicate what type of equation this is, and this is, again, a single displacement, or you can call it a single replacement. That means the same thing. Your magnesium is replacing the silver, so it's a single replacement. Okay, there's going to be practice problems listed after this particular lecture that I'd like you to complete. I will say that writing word equations can be on the more challenging side, so it's really important that you do practice these problems. I don't give you a ton of practice on this today. Sometimes I give you additional practice later on before we start working on other types of problems, but really utilize this entire worksheet and try to do every problem, and then make sure as you're working that you're also checking the key.